Hey, all you cool cats and kittens. Lynn's here. Going to talk to you a little bit first on some notes before we get going on to I want to do this example here on day number one. But before we can get to that, we got to talk a little bit first about some background information, if you will, to go along with that stuff. So, first off, we're going to be talking navigation. Now, remember that navigation has zero up top. Okay? Navigation's got zero going north, and then 90 is to the east. 180 degrees is to the south, and 270 degrees is to the west. Okay? So that is navigation. Okay? Now, what we're going to be doing today is we're going to be taking navigation and we're going to be converting it back into trig. Now remember, with trig, 0 degrees is here, 90 is straight up, 180 is out to the left, and 270 is down. Okay? So we're going to be going back and forth between those two a lot in the navigation realm. Okay? One of the things that I'd like to talk to you about too in regards to this is wind or current. Or I shouldn't say wind or current. Let's just say wind for that matter. Wind is going to be coming from. It's going to be a from wind velocity. So because it's going to be from, sorry, my screen freezes up for the first 5 seconds. So because it's going to be from, so if we said that the wind was from 100 degrees, okay, so first off, I would find the bearing of 100, so that would be 0, 90, 180, so that would be down here with a 10-degree angle in here. That would be where my wind is from, okay? And so the wind would actually be blowing that way with a 10-degree angle there because it's from this 100 degrees, okay? So 90 plus 10 there, so that sets where my vector is, and it's coming from there, so it's going the opposite 180 degrees away. Okay? So if we were where it was going to, it would be going to 280 degrees, or if we wanted to use the trig angle for it, the trig angle would be 170 degrees, because now with trig, 0 is there, 90 is there, and 180 is there. Okay? So we're going to need to be talking about knowing where the wind is coming from. So if it says that the wind was from 100 degrees, first we set our angle, our bearing angle at 100 degrees, and then we go with that through the origin. We reflect that through the origin. So we're in a 5-second freeze frame here. And we're back. I don't know why it does it, but it does it all the time with 5 seconds. Okay? So the last thing that I want to talk about on this video is the formula that you are going to use for all of your navigation type problems. So it's a vector formula. A plus W equals G. Sorry, I paused it. But we're back now. Okay? A, that's going to be your vehicle, your vessel, if you will. And that's what you are going to aim. Okay? So you're going to set out on this course. Then what's going to happen is as you can see from this plane that's trying to land, okay, the wind is going to affect your vehicle. Or if you're a boat, the current is going to affect your vehicle, okay, or your ship. Okay? So that's going to have a vector, and that vector is going to have to come into play at some point in time. Okay? So that W, or this W in here, this is your, wind vector, or your current, if we are sailing a ship. Okay? So those two, when I add them together, is going to equal G, and G is going to be your true course. Okay? So whatever you want the plane to do, or you want the ship to do, plus the outside forces that are working on it, in this case it's the wind or the current of the water, is going to equal the trueness. That needs to be written down on your note sheet. Go back here to some planes taking off as I find us our note sheet. Okay, I would put that on your note sheet right up in here. Okay, A plus W equals G, because we're going to utilize that every single problem when we're dealing with navigation. Okay. This concludes video number 1. The next video that I will post will have this example. A plane has an airspeed of 450 miles per hour on it, and we'll be going through that one.